Hey everybody, Matt Morgan here. In this video, we're going to talk about empirical and molecular formulas from OpenStax Chapter 3. We'll define what an empirical and molecular formula is. We'll talk about how you can find the empirical formula and finish up with an example from the homework. So what is an empirical formula? An empirical formula is the lowest whole number ratio of atoms or ions in a molecule or ionic compound. Ions in a substance like sodium chloride attract each other in 3 dimensions. It's not just a single attraction between one sodium ion and one chloride ion. We build a 3-dimensional array. Every sodium ion attracts all of the chloride ions next to it, and every chloride ion attracts all of the sodium ions next to it. Depending on the size of our sample, we could have an immense number of sodium and chloride ions. But regardless of the number of ions, the ratio is always 1:1. And that's why the empirical formula is NaCl, 1 sodium ion, 1 chloride ion, the lowest whole number ratio. Covalently bonded molecules are different from ionic compounds. They're made of discrete numbers of atoms that have a single attraction to another atom. Hydrogen peroxide has a formula of H2O2. And there's what the molecule looks like. The oxygen atoms are attracted to each other and to one hydrogen. The empirical formula of this would be HO, but that doesn't accurately define what this molecule is. Hydrogen peroxide is 2 oxygens and 2 hydrogens. Some substances have the same empirical and molecular formulas, and water is a classic example. 1 oxygen atom, 2 hydrogen atoms. Usually, empirical formulas are used with ionic compounds. Molecular formulas are used with molecules. An example, fructose has a molecular formula of C6H12O6. There's 6 carbons, 12 hydrogens, 6 oxygens. But sometimes they do use the shorthand empirical formula of CH2O, and that is why fructose and other similar molecules are called a carbohydrate. 1 carbon with the water. And there actually aren't water molecules, but the ratio of carbon to hydrogen to oxygen is the same as carbon to water. So how do you calculate empirical formulas? Common question, chemistry problem has you calculate the number of atoms, or they give you the amounts of atoms in a substance and have you calculate the molecular formula. There's problems like this on the homework, so they can be on the quizzes, so they can be on the exams. The first step to solving this type of problem, convert the given amounts to moles. And you've seen how to do that in the mole video that we've made. Okay, after you convert to moles, you want to divide all the mole quantities by the smallest number. And that should give you a series of whole numbers. And that is your empirical formula. That doesn't make a lot of sense to explain it that way, but let's work an example. And I think it will make a lot more sense. Homework problem 37B has you determine the empirical formula for a substance that has the following percent composition. It's 40.0% carbon, 6.7% hydrogen, and 53.3% oxygen. Your first step is to convert these values to moles. If they give you grams, just use the atomic mass to convert from grams to moles. In this case, we're given percentages. So anytime you're given a percentage, assume you have 100 grams, then the percent becomes grams. So for this problem, our given information becomes 40.0 grams of carbon, 6.7 grams of hydrogen, and 53.3 grams of oxygen. So let's convert to moles. There's our 40.0 grams of carbon. The atomic mass of carbon, 12.01 grams per mole. Using dimensional analysis, our grams of carbon cancel. Mathematically, we'll take 40 divided by 12.01, and we get 3.33. Let's find moles of hydrogen. 6.7 grams of hydrogen. The atomic mass is 1.008 grams per mole. Grams cancel, and we get 6.65 moles of hydrogen. Moles of oxygen. 53.3 grams. The atomic mass is 16. Perform our dimensional analysis, divide 53.3 by 16. We get 3.33 moles of oxygen. There's our moles. Next, the smallest number is 3.33, so let's divide all these values by 3.33. For carbon, that gives us 1. Hydrogen, 1.997, which is really close to 2, so we're going to call that 2. Oxygen is 1. The empirical formula is CH2O, and we are finished. That's all there is to it, to finding the empirical formula. It's not that difficult, just a little bit of bookkeeping. So because the empirical formula is CH2O, the substance must be some kind of sugar. So if you have questions, contact me via email. We also have office hours Tuesday and Thursday mornings using the Blackboard Collaborate. You can also make an appointment if those times don't work for you.